Hi, I'm Pallav from Just Tutors, and today we are going to learn about separating components of a mixture. These are the points we are going to cover today. Like, is the dye in black ink is only the single color, or do we have different colors in that? And then we'll find how to separate a mixture of two miscible liquids. Miscible liquids are the liquids which don't, when we mix them, they don't create separate layers. And then we'll find how to get the different gases from air, and how can we obtain pure copper sulphate from an impure sample. Let's move on. So before we move further, I want you to try these questions. You can pause the video, try these, then we'll move on. Well, these are the answers of given question. I hope you got the correct answers. Now let's move on. So first question, is the dye in black ink a single color? Well, we can get the answer of this question by an experiment. So we will take a paper on which we will put a drop of black ink, and as the arrangement is shown, we will put that paper in the beaker with the water. In this beaker we have water level till here, so we will maintain the height of that drop so that it can just touch the water. Well, normally we use filter paper to do this. So when the filter paper is immersed in the water, and this drop of ink, which can be left for some time so that it can dry, and then when it touches the water, slowly water starts moving up in the filter paper, and with that we see the slowly different colors on the paper. We can see as the water moves up in the filter paper, with that we get the different colors on the paper. And why is it happening? It is happening because this dye is not a single color, it is a mixture of different colors. I use the word dye because when the ink dries, ink is a mixture of dye and water. Now when we have a dye, when the ink dries, we are left with dye. So we have different colors. So by this we can understand that this black ink is a mixture of different colors, which have here the different colors have the different solubility in the water. So the color which has more solubility will appear at the different height, and the color which has less solubility, means the color which is easily soluble in water, will come first, will and then the water which then the color which is not easily soluble come later. So in this way we can have different colors in that, and this process is called chromatography. Normally it is used to separate different colors. Now let's move on to find the next question. How can we separate mixture of two miscible liquids? We discussed that miscible liquids are the liquids which don't form the separate layer when we mix them. So we have discussed how to in the previous videos we have found how to separate the mixture which have the, the immiscible liquids. But here we have miscible liquids, so we will use the method distillation here. So the basic principle behind this method is the difference in the boiling point of two miscible liquids. Like water has the boiling point 100 degrees Celsius and the acetone has 56.5 degrees Celsius. So whatever we do, we can see in this arrangement. Here we have mixture of water and acetone. When we heat it up, then as the boiling point of acetone is 56.5 degrees Celsius, at this temperature it starts vaporizing, and we can get the vapor of acetone at this temperature. So acetone will travel here, and this is the water condenser which will cool it down, and we can get the acetone here. and at 56 degrees Celsius, 57 or 60 degrees Celsius, we cannot, the water doesn't evaporate, so we will have water here and acetone here. So with this method we can separate two miscible liquids. Now another important question: how can we obtain different gases from air? So we know the air is a mixture of nitrogen, oxygen and carbon dioxide as well. So how can we separate that? Well, we will use fractional distillation for this. So as the flow chart is telling, like first of all, air is in gaseous form, so we want to convert that into liquid form, and that can be done when we decrease the temperature and increase the pressure. So first we increase the pressure and decrease the temperature of the air sample. Now we have the liquid air, and then we'll allow to warm this air slowly in the fractional distillation column. So there is a arrangement, the fractional distillation column, which is used to obtain the different gases. So now we have all the gases, the mixture in the liquid form, so they have some boiling points. So all three gases has different boiling points. So oxygen now we have in liquid form, so oxygen liquid has the boiling point of minus 183, then argon has 186, then nitrogen had 196. These are in minus 186 and minus 196. So when we are slowly heating up, when we are heating up these air samples slowly, when the temperature would be, and at different heights in the fractional distillation column, at different height we have different temperature. So when the oxygen reaches 183, at that particular height we can separate oxygen. In the same way other gases can be separated. And now the last one: how can we find the pure copper sulphate from an impure sample? Well, for finding the pure copper sulphate we use the process of crystallization. So what do? We have the impure copper sulphate crystals, which we put in the water, in the minimum amount of water. So again, then we have the impure solution. Now we can filter out the impurities which are not soluble in water with the filter paper. Then we'll heat up the solution. So we will heat up the solution until we get the saturated solution. Now where very less water is in there, then we will take this out. We will not further heat, we will leave it so that it can cool for a day, and then we will have the pure copper sulphate crystals. Now we have some practice questions, so I want you to try these questions. You can pause the video, try these questions, then we'll move on. Well, these are the answers of given questions. I hope you got the correct answers. And about three we have discussed, like miscible are the liquids which don't form layer, and immiscible form layers. So thanks for watching this video. For more you can visit justtutors.com. Thank you.